Dear students, Assalamu alaikum and welcome back to the plant physiology course with the discussion of plant-water relations. We were discussing diffusion, and in the previous video it was explained that how we can describe the process of diffusion taking advantage of second law of thermodynamics or Gibbs free energy and the chemical potential concept. Now finally we are going to take a look at various factors that affect diffusion. So factors affecting diffusion. There are few factors that affect the rate of diffusion, whether it's a gas or solute in the liquid, solids in the liquid, or liquids in the liquids, since there are very different types of solutions. One of them is temperature. And it is very obvious, and we can easily understand keeping in view the discussion that we have seen so far. Temperature is another name for the kinetic energy of the molecules. One thing that I would like to emphasize that our discussion of these factors which affect the rate of diffusion will be very simple. We are not going to go into any details or mathematical details. We are going to keep it as simple as possible. Since temperature is the kinetic energy, and we can easily understand that if we increase the temperature, the rate of diffusion must also increase, and this is the case. So the temperature and the rate of diffusion, increase in temperature and the rate of diffusion are directly proportional. So any increase in temperature, what it does that it increases the rate of diffusion. And what has been given here, it is actually factors affecting, what I forgot to mention here, rate of diffusion. So we are actually discussing rate of diffusion, the factors which affect whether the diffusion will be faster or slower. So increase in temperature increases the rate of diffusion simply because it increases the kinetic energy of the molecule, so diffusion gets faster. Next factor is the density. Density of the diffusing molecules. So this is what we mean by density. And we know what's density, it is mass per unit volume. So the Graham's law of diffusion very accurately describes the relationship of density and diffusion, and it simply states that the rate of diffusion of gases is inversely proportional to the square root of their density, especially the diffusion of gases. Graham's law of diffusion. And we can mathematically explain or write down the law of diffusion. The Graham's law of diffusion is equal to so R1 and R2, these are the rates of diffusion. R1 and R2, these are the rates of diffusion, and D1 and D2 are the densities of two gases. So R1 is the rate of diffusion of gas with the density D1, and R2 is the rate of diffusion of a gas with the density D2. And as you can see, it is inversely proportional to the square root of their densities of the gases. Now what it means that denser the molecule, that is the molecules or atoms with greater density will diffuse slower as compared to gases with molecules having lower density or smaller value of density. Now if we just substitute the values of two very common gases, oxygen and hydrogen, we can get the idea that what does it mean. So say R H for rate of diffusion for hydrogen and RO for oxygen. So it will be 16 under root and 1 under root. Since it is inversely proportional, it is D naught and RD0, RDO and DH. So this is equal to 4 by 1. Now, as you can see from this expression that the density of the hydrogen, density of the oxygen is 16 times that of hydrogen. Oxygen is 16 times heavier than hydrogen, so its diffusion rate of the hydrogen will be 4 times faster as compared to the rate of oxygen. As you can see it very clearly here, that the rate of diffusion will be 4 times faster for hydrogen as compared to oxygen. And in the laboratory we can very easily demonstrate this principle, the Graham's law of diffusion, and we can use two gases. So let's draw a very simple diagram. So let's take a glass tube and we plug both ends of the glass tube with cotton. So let's color it slightly differently. So these are cotton plugs, and they are simultaneously soaked by adding from one side HCl and from other side NH4OH. NH4OH. So this is ammonia and HCl. Now as we add these solutions to these cotton plugs, now what happens that they start diffusing into the tube. HCl fumes will start progressing inside the tube, and similarly so ammonia from this side and HCl from this side. And when these two molecules of these two gases, HCl and NH3, when they combine, and a reaction takes place in which ammonium chloride is formed. Now we know that HCl is much heavier as compared to NH3. Now in HCl we have 1 plus 35.5 is equal to 36.5, the molecular weight of HCl. On the other hand, we have 14 plus 3 is equal to 17. So this is almost twice as heavy HCl as compared to NH3. So according to the Graham's law of diffusion, it will diffuse much faster, and we would anticipate that when these two molecules react with each other, their reaction is indicated by the formation of a white ring. We are not going to draw a white ring, which we cannot draw, so we take a different color, and this ring will be formed closer to the HCl side, because NH3 will diffuse faster, and this ring is that of NH4Cl, ammonium chloride. As this molecule is formed, this compound is formed when HCl and NH3 fumes, they react with each other, and this NH4Cl ring will form closer to the HCl because NH3 will diffuse faster, and it will reach this point before HCl reaches here, and when they combine we get a white ring of NH4Cl. So this demonstrates the Graham's law of diffusion, that is the denser molecules diffuse slowly. So HCl in this case is denser and NH3 has low density, so it will diffuse faster. So this was Graham's law of diffusion. And the next factor which affects the rate of diffusion is the solubility. Solubility in the diffusion medium. Say something is to diffuse in water, so water is the solubility medium. So greater the solubility, greater will be its diffusion inside that medium. For example, oxygen diffusion inside water is much slower as compared to carbon dioxide, because carbon dioxide is much more soluble in water as compared to oxygen. So greater the solubility, greater will be the rate of diffusion. So they are directly proportional to each other. Rate of diffusion is directly proportional to the solubility of the substance in the diffusion medium. So this was the third factor. First we saw temperature increasing, the temperature increases the diffusion rate, and density, lower density diffusion will be faster and higher density diffusion will be slow. And then solubility, greater the solubility, greater will be the rate of diffusion. And finally, we have chemical potential gradient. And we have already seen this concept in terms of concentration gradient. So we discussed that if there is a difference in concentration gradient and the difference is greater, the gradient is greater, the diffusion will be faster. So similarly, now we are talking in terms of chemical potential gradient. So steeper the gradient, faster will be the diffusion. Faster will be the diffusion, because chemical potential is the driving force behind the process of diffusion, and we have already seen that chemical potential is the amount of free energy available per mole of a substance. So greater the free energy available, faster will be the diffusion. So these were various factors that affect the rate of diffusion: temperature, density, solubility in the diffusion medium, and finally chemical potential gradient. So with this, we end this discussion of diffusion, and from the next video, we shall start, inshallah, the discussion of osmosis, water potential, and so on. So thanks for watching, and see you in the next video.